Hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at EFS or Elastic File System and this is a lab. You will need to log into the console, but first we're just going to cover off from a theoretical point of view what EFS actually is, and EFS is now in the exam, so you do need to understand EFS and basically its use cases. So what is EFS? Well, EFS is Amazon's Elastic File System, and it's a file storage service for Amazon Elastic Compute Cloud, or EC2 as it's called. So Amazon EFS is easy to use and provides a simple interface that allows you to create and configure file systems quickly and easily. With Amazon EFS, storage capacity is elastic, growing and shrinking automatically as you add and remove files. So your applications have the storage that they need when they need it. So if you think back to some of our other labs where we had EC2 instances and we were attaching additional volumes to those EC2 instances, what we had to go in and do is pre-provision those EBS volumes. So we had to go in and say, okay, I want an EBS volume of SSD storage that's 8 gigs in size. We go and provision that EBS volume, and then we would attach it to that EC2 instance. We would then have to mount that to a particular directory, etc. So it's great and that works, but at the same time you can't mount an EBS volume to two EC2 instances at once, and that's what EFS allows you to do. Let's quickly just go through the features of EFS. So it supports the NFS version 4, NFS v4 protocol, and you only pay for the storage that you use. There's no pre-provisioning required. So it's not like EBS where we have to spin up an 8 gig volume. We actually just start putting files on it, and we're charged 30 cents per gig in terms of storage costs, and that's it. It can scale up to the petabytes, and it can support thousands of concurrent NFS connections at once. And the data is stored across multiple availability zones within a region. Now, again, we don't actually get a durability rating from Amazon, to my knowledge, at least to what I could research, but that's because it is quite new. So it's not going to be like S3, where we get the 11 nines durability just yet. But hopefully as they develop it, we will get a definite durability rating. Now, the cool thing about EFS compared to S3 is EFS is block-based storage as opposed to object-based storage. So, we can put files in there and we can actually share them with other EC2 instances. And we'll go through how we do that in this lab. And so EFS is very similar to S3 in that you get read after write consistency. But again, I will say it again, EFS is block-based storage, not object-based storage. Okay, so in order to do this, I'm going to go over to the Amazon console. Okay, so I'm in the AWS console right here. I'm in the London region, and we can see EFS under storage. Now, if I click on this in London, I'm going to get an error message, and it's saying it's not available in EU London. You can select a region that's closest to you. I'm actually going to do this out of Oregon because that's where EFS was first built. So I'm going to click on US West. And here's the splash screen. So we go in and we hit create file system. So I've gone in and here's my lovely splash screen, and basically I have to create mount targets. Well, first of all, I have to select my VPC. I'm just going to use my default VPC for this region. I then have to create mount targets, and I can actually choose which availability zones I want to have mount targets in. And I'm just going to click on all 3 availability zones. And then we choose our subnets. So this is if we were using our custom VPC, we might have different subnets, but these subnets are the default subnets for each availability zone. Our IP addresses, we can actually go in there and predetermine our IP address, but if we just leave it blank, it is going to automatically allocate us an IP address. And then these are the security groups. You'll see it's the same security group, and it's the default security group for this VPC. Okay, so here is where we go in and add our tags. So I'm going to call this my EFS file system, and you can see I've already typed it in before. And I'm going to go ahead and hit next. Then we just review the information. So essentially we are putting it within this VPC, within these 3 availability zones. We're assigning it an automatic IP address, and it's going to be assigned to this security group. And then we go ahead and hit create file system, and it's literally that simple. So what I'm going to go and do now while this is being created is I'm going to go in and provision 3 EC2 instances. I'm going to put them in different availability zones. So I'm going to go across to EC2, and I'm going to provision. I might actually just provision 2 EC2 instances to keep this video quite quick. So go in and do our Linux AMI, going to use a T2 micro. I'm just going to use all the standard settings, except I'm going to choose my availability group, availability zone. So I'm going to go into US West 2A. I'm going to go ahead and hit next, add my storage, and we're going to call this US West 2A. I'm going to go ahead and hit my security groups, and the security group I'm going to use is one that I've spun up earlier, so my web DMZ. I'm going to go ahead and hit review and launch, and using that private key. And then I am going to go back and view my instance and launch my second instance. And again, we're going to go through all this again, quick. So we want the subnet is going to be 2B this time. Go ahead and hit next, and I'm going to call this US West 2B and hit next. And I'm going to use my pre-existing security group, which is my web DMZ, hit review and launch. And again, I'm going to launch it using this key pair that I've set up earlier. Okay, so now that that's done, I'm also just going to go in and provision a load balancer. You'll see why in a second. So we'll create this load balancer. We'll just call it my production LB, and we're going to create it within the default VPC, and we're just going to let it have port 80, and I'm going to put it in the same security group and hit next, and hit next, and we're going to configure a health check, and it'll just be our standard health check, except I will change the healthy threshold to 3 and the health check interval down to 10 seconds, just so that it comes online very quickly. And then I'm going to add in both my EC2 instances. Now, of course, this is going to fail the health check until I actually go in and start installing that index.html file. And just going to hit review and create. So there we go. We've got the Elastic Load Balancer created. We've got 2 EC2 instances that are online. If we come back here, we should be able to see our Elastic file system should hopefully be ready. And yeah, it's available in all 3 availability zones. So here we go. Now what I'm going to do is I'm going to come over here and I'm going to note down the public IP addresses of my 2 instances, and I'm going to log into them. Now I have been playing around with this a bit in the video, just making sure everything works before I record. So you can see a lot of different terminated instances here. But here are my 2 instances, and before we do this though, there's one important point. We need to make sure that these instances are within the same security group as the EFS mount point that we just created. So we need to go in and go to actions. We need to go over to networking and go to change security groups, and we want to make sure that it's these EC2 instances are also within the default VPC security group. So I'm going to do that for US West 2A, and for US West 2B do exactly the same thing. Go ahead and change the security groups, and so there we go, assign security groups. So there we go, our 2 EC2 instances are within separate availability zones. They're behind an ELB. They are both now running, and they are in the same security group as our EFS volume. And if we just go check on EFS, you can see what security group it's in just by reading here. So it's the default security group. So if I now go back to EC2, I'm going to make a note of the 2 public IP addresses, and we're going to run 2 different terminal windows, and they're going to be different colors, so you can see which one. I think US West 2A will make blue, and US West 2B will make green. So I'm just going to pause the video as I get the terminal windows set up. Okay, so I've logged into 2 different terminal windows. The blue is US West 2A, and the green is US West 2B. And so I'm just going to go ahead and log into both instances. So go ahead and hit yes, and that's connecting in now. And I'm going to go ahead and hit enter and type in yes, and that's also connected in. So I'm going to raise my privileges to root, and I'm going to clear the screen. Do the same here, raise my privileges to root, and then clear the screen. First thing I'm going to go in and do on both of these instances is install Apache. So yum install httpd -yes, and the same goes here, yum install httpd -yes. So we've installed Apache on both. The next thing I'm going to go do is start the Apache service on both. So service httpd start, and then on the other ones, service httpd start. There we go. And so started on both. And so now when we've done this, it's basically created the var If we go across here, it's created the var www.html or /HTML, and you can see there's nothing in there. So I'm going to go and clear the screen. I'm going to go back to the root. And here I'm going to do the same thing, clear the screen and go to the root directory. Whoops, there we go. So the next thing we need to do, if we go back over to EFS, so what we need to now do is go over to EFS, we'll click on it here. It's really simple. We click in here and you'll see File System Access EC2 Mount Instructions, and you can click in here. Now, because we're using a Amazon Linux AMI, we don't actually need to go in and do any of this. We don't need to install anything. It's already pre-installed for us. All we need to do is run this command to mount our instances. But this is going to mount it to the EFS directory, and we want to mount it to our var www.html. So I'm going to go back to my terminal window. I'm going to paste this command in here, and I'm just going to change it so that it goes to var www.html and hit enter. And I'm going to do the same for this one here. Go to /var /www/html. Now, what's really cool is if we now go to our var www.html, this is mounted on EFS, and we can start creating files. So go nano index.html, which is what our Elastic Load Balancer is now looking for its health check. I'm going to call it, just type in hello cloud gurus, this is my new homepage, and I'm going to save this, hit yes, and hit enter. Now, if all has worked, we can go back over here, and if we go to our var www.html and do an ls, and if you can see there's now the index.html. If we actually go in and have a look at what the data is in there, it will hopefully, or obviously, is going to be the same as what we just saved. So it's the same file, and it's basically, we've now just got one copy of our code, but we've got two web servers serving up this content. And I'm going to now go back across here. I'm going to go over to my Elastic Load Balancer, and with any luck, this will now be in service. So if we come back over here, go to our load balancer and go over to our instances, and there we go. It's now passing the health check. It's finding index.html. And if we browse to the actual DNS name, I'll click on the description and go to the DNS name of the load balancer. It's going to load that file that we just created. So I'll go up here. And there we go. Hello Cloud Gurus, this is my new homepage. And so you can see how amazing EFS actually is, because it means that you don't need to have multiple copies of your code. You don't need to mess around with bash scripts that pull your code down from S3 upon provisioning new EC2 instances. You can actually all just have your code in one centralized repository, and then you can have EC2 instances that auto scale and then mount that EFS mount point as the root directory for Apache. So it saves you a lot of time. So EFS is now out of preview. It is generally available. It's only available in some regions currently, but hopefully you're able to find a region close to you to do this lab using the EFS service. Now, EFS is in the exams now. It does feature as a question, and what's important to remember is the use case for EFS. So what is it that you're actually using it for? And essentially, you're using it as a file server. You're storing your files there. You're making it a centralized repository, within your EC2 instances. So you can have multiple EC2 instances all connecting into the same EFS volume and all basically accessing the same files. And you can also apply to EFS user level permissions and directory level permissions. So you could, basically make directories restricted in EFS, and that would be universal across all EC2 instances. So let's say you've got your payroll folder and you want to restrict access to that. You might change the permissions on that directory so that only certain users could go in and access that. And you can definitely do that with EFS. You can restrict at both a file level and at a directory level. So just remember the use case for EFS going into the exams. It's a perfect thing for a file server. You might be given different scenarios around EC2 and whether you should be using EBS volumes versus EFS volumes. Just remember that EFS allows multiple EC2 instances to connect to it, whereas EBS can only be mounted to a single EC2 instance. Okay, so that's it from me, guys. Hopefully you've enjoyed this lecture, and feel free to move on to the next one. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. So AWS released Lambda at reInvent in 2014, and it actually revolutionized the way cloud computing is done. It was basically the invention of serverless. And that's how we've built our A Cloud Guru platform. We've built it on serverless technology. And if you're watching this on the A Cloud Guru platform right now, you are directly interacting with Lambda. So in this lecture, we're going to cover off what Lambda is. Now, Lambda has taken a little while to start appearing in the exams, but it is definitely an exam topic now, and you are going to get several questions on Lambda. So in this lecture, we're going to introduce Lambda and show you what it is. In the next lecture, we're going to build a serverless website using Lambda and API Gateway. And then in the next two lectures, we're going to build a serverless application that uses a whole bunch of different services. It's going to use S3, it's going to use Poly, it's going to use Lambda, and essentially it's going to help you study for your exams. So this is the most interesting part of the course, in my opinion. You've gone from using EC2. Now let's look at the future and look at what serverless actually looks like. So let's get started. So to get started, why don't we talk a little bit about the brief history of cloud? I'm going to try and teach you all about the history of cloud in 2 minutes or less. So if you're a developer like me, you don't really like computer hardware. You know, it's heavy, it's cumbersome, it breaks. So we've spent the last couple of decades building layers of abstraction over layers of abstraction in code to shield ourselves from the ugly truth of what's really running our code. And basically, first we decided, hey, let's chuck all our hardware in a data center somewhere, and someone else can be responsible for making sure it's turned on, connected to the network, etc. And then basically, hooray, we no longer have to get out of our chairs. But provisioning the infrastructure is not fun. You know, we had to talk to people, we had to call or email the data center provider, and it would take them a while to get access to the new machines. Like when I worked at Rackspace, a typical delivery time frame would be around 10 days. So when you place an order for that, database server or web server, it would be a 10-day provisioning time before it was ready for you. And then in 2006, Amazon launched EC2, and it was a complete game changer. Suddenly you could provision machines with API calls from the command line or from your web browser, and it was heaven. And infrastructure as a service was born, and developers all around the world got really happy and basically cheered because they didn't have to, provision physical servers anymore. AWS is basically infrastructure as code. I mean, think about what you can do now. You can provision a virtual machine anywhere in the world and have it doing whatever it is you want, just using API calls. So that was great. That was the birth of infrastructure as a service. But the problem with infrastructure as a service is it's still running on, servers. It's still running on virtual machines and physical machines as well. So you have to worry about what the operating system is doing. You still have to manage Windows. You still have to manage Linux. If you have some kind of corruption on the disk, you might lose your operating system. You might need to have to reinstall it. So infrastructure as a service only goes so far. Then Azure and Amazon came out with Platform as a Service, and in the Amazon world, it's Elastic Beanstalk. And basically, Platform as a Service was a really nice way of just uploading your code, and then Amazon would basically take a look at that code and provision the underlying resources for you. So they would create the web servers for you, for example. And that was great because you didn't really have to know all that much about infrastructure. You could just be a developer and upload your code and let Amazon handle it for you. We still have the same problem. You're still managing operating systems. You're still managing Windows. You're still managing Linux, and Amazon wouldn't do that for you. Then we had containers, and containerization has been gaining a lot of popularity in the last few years. So the most obvious one is Docker, and we have a whole bunch of Docker courses on the A Cloud Guru platform. And later on in the course, we'll talk a bit about Docker and what Docker is and how Amazon's Docker offering ECS works. But we won't talk about that just now. We will come to that later on in the course. So containers are isolated and they're lightweight, but you still have to deploy them to a server, and you still have to worry about keeping your containers running and scaling them into response to load. So you still have something that you have to manage. And then Lambda was released in reInvent 2015, and it was a complete game changer because suddenly you didn't have to worry about managing data centers. You didn't have to worry about managing infrastructure as a service. You didn't have to worry about managing platform as a service. You didn't have to worry about managing containers. Amazon takes care of all that for you. Literally, all you have to worry about is your code. So you take your code, you upload it to Lambda, and then you configure an event trigger. So what's going to trigger your Lambda function? So what is Lambda? Well, Lambda is basically encapsulating your data centers, your hardware, your assembly code and your protocols, all your high-level languages, all your operating systems, all the application layer and AWS APIs is encapsulated by AWS Lambda. So you don't have to worry about managing any of it. You literally, all you have to worry about is your code. So the official explanation from Amazon is AWS Lambda is a compute service where you can upload your code and create a Lambda function. AWS Lambda takes care of provisioning and managing the servers that you use to run the code. You don't have to worry about operating systems. You don't have to worry about patching. You don't have to worry about scaling. And you can use Lambda in the following ways. You can use it as an event-driven compute source where AWS Lambda runs your code in response to events. And these events could be anything such as like changes to data in an Amazon S3 bucket or in a DynamoDB table, etc. And it also runs as a compute service to run your code in responses to HTTP requests using the Amazon API gateway or API calls made to the AWS SDKs. And this is exactly what we use at A Cloud Guru. Okay, so we covered off the two ways that Lambda can be used, but I just want to show you visually to reinforce the message. So the first way is when we react to a particular event or trigger. So let's say we've got our user and our user wants to create a meme. So they upload this meme to S3. And as soon as we upload our meme to S3, it triggers an event, and this is a Lambda function. So this Lambda function might take our meme and the text that we've supplied with it perhaps, and then basically encode that over the image and then store the image in S3. Now our Lambda event might then trigger another Lambda event, and this is basically returning the image location of the new file back to the user. It might then trigger another Lambda event, which will then take the image that's in this S3 bucket and copy it across to another S3 bucket somewhere else in the world. So Lambda events can trigger other Lambda events. They can also communicate with other AWS services. So you could be sending information to SQS or SNS, which then goes on and triggers further Lambda events. And it's really important to understand that each instance, every time you do something with Lambda, that is just one instance of Lambda running. So if we had multiple users uploading multiple memes, it would create, or it would invoke multiple Lambda functions. The code itself would be the same, but the actual invocation would be completely different. And this could be happening on a server in a completely different availability zone, etc. And the great thing about Lambda is that it scales automatically. It scales out so that you don't have to worry about maintaining things like elastic load balancers. And often in IT, we have a thing called scales up versus scales out. Scaling up is when you're increasing the amount of resources in something. So it might be increasing the amount of resources in terms of RAM. You might be going from 4 gigs to 8 gigs or to 16 gigs, etc. That's scaling up. Scaling out is where you're adding more and more instances, for example. So think of things like load balancing. So as you get more and more load, you scale out rather than just scaling up your EC2 instance. And the great thing about Lambda is it scales out automatically. You can have one function, literally it can be just a 2-line function saying hello world, but if a million users hit Lambda at once trying to request that function, automatically a million different functions will be deployed and that will be returned to the user. So that's important to remember as well. The main thing to remember going into your exam is the different types of Lambda triggers. And to get that, let's go have a look at the AWS console. Okay, so here I am in the AWS console. You'll notice that my region is Northern Virginia. When you're doing Lambda triggers, some triggers are only available in certain regions. So if you want to check what triggers are available, I choose Northern Virginia. Northern Virginia will always have basically all of the AWS services. It's always rolled out to Northern Virginia first. You'll find Lambda here under Compute. So if you just go ahead and click on Lambda, Not sure if I have any functions already in this account. Yes, I do have some functions in this account already. What you want to do is just go ahead and create a new function. You might get a dashboard or a splash screen, but just go ahead and hit create new function if you don't already have a Lambda function. You can see up here we've got three different ways of authoring a function. So we can author from scratch, we can use blueprints, or we can use the serverless application repository. I'm going to go ahead and just author from scratch. In here, I'm going to call it my test function. So my test function. Doesn't matter what runtime environment. Go ahead and choose Python if you want. But in here, do note the different runtime environments that you can choose from. So we've got C#, we've got Go, we've got Java, we've got Node.js, and we've got Python. Do remember that going into your exams. With role, you can choose an existing role or create a new role from template. I'm just going to create a new role from template and call it my Lambda role. So my Lambda role. In here we have our policy templates. It used to be called the Lambda Basic Execution Role. They've now renamed it to Simple Microservice Permissions. This will give you permission to execute your Lambda function. So go ahead and create your function. Once your function is created, you are then able to go in and configure your triggers. So there we go. It's now created my test function. In here, we can see our triggers. So click on a trigger from the list below to add it to your function. So these are all the different triggers, and you will be tested on this in the exam. So it's important to remember them going in. So we've got API Gateway, we've got AWS IoT, we've got the Alexa Skills Kit. So every time you basically trigger Alexa, it's this trigger that is basically making your Lambda function fire. So if you say, Alexa open a Cloud Guru, it's the Alexa Skills Kit that's triggering that function. We've got Alexa Smart Home, we've got CloudFront, we've got CloudWatch Events, CloudWatch Logs, we've got Code Commit, we've got Cognito Sync Trigger, we've got DynamoDB, Kinesis, S3, and SNS. Don't worry, you probably don't need to remember all of these, but you do need to understand the core ones, so such as API Gateway, the Alexa Skills Kit, CloudFront, CloudWatch, and then DynamoDB, Kinesis, S3, and SNS. Those are the major ones I would remember going into the exam. So you might be wondering what all these different triggers are. You can go away and have a look at that, but what we will now explore is what API Gateway is, because again, this features quite heavily in the exam and is intricately linked to Lambda. So we previously mentioned how Lambda could be used, and we looked at it as an event-driven compute service, and we looked at the example of creating a meme. You can also use it as a compute service to run your code in response to HTTP requests using Amazon's API Gateway. So let's have a look at what that looks like. So here we go, we have our user, and our user is browsing, let's say in Google Chrome, and they want to go to our website. So they're going to send a HTTP request, and that is going to go to API Gateway. That will then trigger a Lambda function, and it could just be, that the user wants to see a discussion forum on a website, for example. Lambda will then return that response back to the user. Now, the great thing about this is it scales out automatically. So if we have two users sending two HTTP requests, that's going to trigger two Lambda functions, and they're both going to respond back with two responses. So this can get a little bit confusing, but it's a really important exam topic. And basically, every time a user sends a request to API Gateway and that's forwarded to Lambda, you're invoking a new Lambda function. So if you've got two users sending two HTTP requests, you're going to invoke two Lambda functions. If you've got three, you're going to invoke three Lambda functions, etc. What doesn't happen is if you've got three users, let's say they're all connecting at the same time, the one Lambda function isn't going to respond to that. It's going to be multiple Lambda functions responding to that. Now, inside the actual Lambda function, the code is identical. That's what the function is. It's one set of code, but it will respond to multiple requests. So that's really important going into the exam, is to understand that. And it's very different to using like EC2 with elastic load balancers. Let's say you've got two web servers behind an elastic load balancer. Those two web servers are the ones that are always going to respond. It doesn't matter how many users that there are. But if you've got a single piece of code in Lambda, that Lambda function will scale out automatically. So if you've got 1 million users hitting your website at once, that's going to invoke 1 million Lambda functions. And interestingly enough, you get 1 million free invocations per month. And we'll come on to that in the pricing slide. So let's talk about what languages are supported with Lambda. We've got Node.js, we've got Java, we've got Python, and we've got C Sharp. So we can see what our languages are supported by just going to the Lambda splash screen, clicking on create a function, author from scratch. You don't need to select a trigger, and then just going in here and we've got our different runtimes. So we've got C Sharp, Java 8, Node.js 4.3, Node.js 6.1, Python 2.7, and Python 3.6. Now you're never going to be tested on version numbers, to be honest. It's just the overall language. So remember Python, Node.js, Java, and C Sharp. And I would expect this to, change and more languages be added very, very soon. So how is Lambda priced? Well, it's priced based on the number of requests. And like I mentioned earlier, the first 1 million requests are free. And then after that, it's 20 cents per million requests thereafter. And believe it or not, the A Cloud Guru platform only started getting a Lambda bill about 6 months ago, and we've serviced over 250,000 students. I think we're actually almost up to 300,000 now. So Lambda is really, really disruptive in terms of cost. If you can build your serverless applications using Lambda, you're basically going to have a very low cost. You're not paying per minute, or you're not paying by the hour. You are literally paying as somebody tries to request your content. So it's an amazingly disruptive technology. You're also built on duration, and duration is calculated from the time your code begins executing until it returns or otherwise terminates, and it's rounded up to the nearest 100 milliseconds. And the price depends on the amount of memory you're allocated to your function. And you're charged, I'm not even going to try and pronounce that, it's a ridiculous amount for every gig per second used. And of course that can change, and you'll never be asked how much the charges are in the exams. It is important to remember that the duration has an maximum threshold, and that threshold is 5 minutes. So your function cannot execute over 5 minutes. If your function is going over that, you're going to have to break your function up into multiple functions and then just get one function to trigger the next one. So why is Lambda cool? Well, no servers. You don't have to worry about maintaining and managing servers. And if you think about that, that means no database administrators, no network administrators, no system administrators. You don't need any of that. You literally can just focus on your code. It also provides continuous scaling. So as if you've got 1 million users hitting API Gateway itself will scale automatically to handle that load, as well as Lambda will scale automatically to handle that load. So it's not like auto scaling, which will have a whole bunch of rules and scale up automatically, but it might take a couple of minutes. Lambda scales instantly, and that is why it is seriously cool and powerful. And it's super, super, super cheap. This is why people like us are disrupting, other industries. So if you think about some of our big competitors who provide online education, they have their own data centers, they have their own system administrators, network administrators, etc. At A Cloud Guru, we literally just have our developers and we put all our code up into Lambda, and it just scales automatically with our customers. So if you want a practical use case for Lambda, think of the Amazon Echo, or sometimes referred to as Amazon's Alexa. Every time you're speaking to Alexa, that is invoking a Lambda function, and that is basically Lambda speaking back to you. So that's a very practical use case. And in fact, the best way to get hands-on experience with Lambda is to go and create your own Alexa skills. We actually have a free course on that on the A Cloud Guru platform. We also have a much more in-depth paid course where you go out and develop, I think it's like 10 or 11 skills. And it's so much fun. So if you do have the time, make sure you check that out. So what are my exam tips? Well, Lambda scales out, not up, automatically. Lambda functions are independent, so one event will equal one function. Lambda is serverless, and it's important to understand what services in AWS are serverless going into the exam. So make sure you understand that. So things like S3, API Gateway, Lambda, DynamoDB, etc. EC2 is not serverless because you're managing EC2 instances. Also remember that Lambda functions can trigger other Lambda functions. So one event can trigger an X number of functions. So you could have the fact that somebody uploads a picture to S3, that triggers a Lambda function. That could fire off an SNS notification, which triggers off another 10 Lambda functions. So it's not that one event always equals one Lambda functions. You can have multiple Lambda functions from one event. Also remember that architectures get extremely complicated. So debugging this, I mean, if you're using API Gateway, S3, DynamoDB, using Lambda, you might be using cross-region replication. It can be a nightmare to debug when something's going wrong. For that reason, you've got the AWS X-Ray service and allows you to debug what is happening. Also remember that Lambda can do things globally, so you can use it to back up S3 buckets to other S3 buckets, etc. Also understand what AWS triggers there are for Lambda, so know what services can trigger Lambda. Remember that Lambda's duration time is a maximum of 5 minutes. And then, of course, always remember what different languages are available for Lambda. So that is it. We're going to get really hands-on now. We're going to go ahead and build a serverless website, a very simple one that just says Hello Cloud Gurus using API Gateway and Lambda. And then after that, we're going to do something much more fun. We're going to go ahead and create a serverless website that will convert any text that you post into that site. It'll convert it using the Poly service into audio. So you might want to start taking some notes. You might want to put that into this website, and then you can download your notes as an audio file and listen to them on your way to work. So it is lots of fun. So if you've got the time, please join me in the next lecture. Thank you.